Good morning, grade 7s. Welcome to your daily lesson of mathematics brought to you by WorksheetCloud. I hope you guys are all well and looking forward to today's lesson. A reminder of the email address on your screen, grade7@worksheetcloud.com. Please feel free to use it. Send me any feedback or queries, or perhaps there's a topic that you'd like me to go over in more detail, and I'd be happy to do that for you. Our schedule for today, our main theme is volume and capacity. We have our warm-up and our mental maths questions covering previously taught principles, just to keep those concepts fresh in your mind. And then we've got the normal brain benders and challenges for you to finish off on. Right, let's get into our warm-up for today. So let's get straight into our warm-up activity. There's a GoPro, a battery, and a drone, as well as a light. And you need to tell me what the value of those symbols are, as well as the question mark at the end. Press pause and then press play to see how you get on. I got it wrong, so it took me a couple of attempts to get the right numbers into the right places, but ultimately you should have 10 multiplied by 10 divided by 20, and the key here is 10 divided by 20 comes first, so that gives you a half, and then 10 times a half gives you 5. Okay, so then we know that 200 is going to be equal to 20 multiplied by 10. And that's all good. Then we get down to the drone, and the drone is going to be 2 because that is equal to 20 divided by 10. Then 40 is going to be equal to 80 divided by 2. Okay, and then right at the end, the drone is going to be 2. The battery is going to be 20, and the light is going to be 80. Okay, and again, you can decide what order to do that calculation in. Remember, you can go 2 times 2 is 4, 4 times 8 is 32, and then you can add the zeros that you need to add. So ultimately, the answer is 3,200. Okay, I hope you guys got that and worked through it. Let's go have a look at our mental arithmetic questions for today. Right, there you have them. 9 questions covering past principles. Give them a shot. Press play to see how you get on. Right, question 1 is an addition of decimals, 26,71 plus 19,75. And I've done that for you on the screen. So if you don't get the answer that I get, then press pause and have a look at my calculation. Question 2 is subtraction, so 36,716 subtract 28,739, and remember we said the important part was to put the correct numbers into the correct columns, and then this question, the important part is also the borrowing of numbers, so we need to make sure that we do that correctly, comma in the same place. And we left with 7,977. So if we check that, 7 plus 9 is 16, 7 plus 3 is 10, 9 plus 7 is 16, and 7 plus 8 is 15. So we know that we must be correct there. 179 multiplied by 14. You guys know by now that there are multiple ways of doing a question like this. So today I'm actually going to use the compensation method. So I'm going to turn 679 into 680 and multiply that by 14. Okay, so ultimately I need to do 68 times 14. So I know that 60 times 14 can be 6 times 14. That's going to give me 60 and 24, that's 84. And we must remember the 0. Okay, 8 multiplied by 14. It's going to be 80 and 32, so 112. Okay, and if I add those two, I'm going to get 952. But remember, I cannot forget that multiple of 10. Okay, so it's 9,520. Now I compensated by adding an extra group of 14. So now at the end I must remove that group of 14. And that's going to give me 9,506. Okay, But guys, remember, there are other ways. You could have used the column method. You could have used the split strategy. I'm just trying to go over as many different methods as possible. Division sum in question number 14, and that is how we can set it out. 5 does not go into 3, so 5 goes into 34 6 times. Comma in the same place, we're left with a remainder of 4. 5 goes into 47 9 times. 9 times 5 is 45, so that leaves us with a remainder of 2. So that becomes 25, and we know that 5 goes into 25 5 times, no remainders, and then 5 goes into that last 5 once. To check this, 6,951 multiplied by 5, okay, and if you go and work that out, you will get 34,755. And again, you can work that out simply by doing a column method because it's a nice short multiplication. And let's just check if we're right. 34,755. We must be correct. Okay, well done. Question 5 is a subtraction of fractions, so a mixed numeral minus a common fraction. So first I'm going to change it to improper. So 9 over 5 minus 1 over 4. Remember, from mixed to improper, we multiply the whole number by the denominator. 1 times 5 is 5, and then add the numerator. 5 plus 4 is 9, and always keep the original denominator. My LCD, my lowest common denominator of 5 and 4 is 20. So 5 goes into 24 times. 4 times 9 is 36. 4 goes into 25 times. 5 times 1 is 5. And if you work that all out, you'll get an answer of 31 over 20. And if the question asked you to convert to a mixed numeral, 1 and 11 over 20. Okay? Good. Okay, question 6. 8,909 divided by 1,000. We know when we divide, the number gets smaller. So if you're dividing by 1,000, that's 3 places smaller. So that's going to give us 8,909. Right, then I'm going to do question 7 at the same time. 5 over 7 divided by 6 can be written as 5 over 7 divided by 6 over 1. So we've got 2 fractions. Then we know that the division sign changes to multiply, and the fraction after the division sign gets inverted. And now we've got 5 times 1 is 5, and 7 times 6 is 42. So 5 over 42. Okay. Question 8 is the multiplication of a fraction. Okay, so 4/5 times 3. We can put 3 over 1. So we've just got our 2 fractions. And then it's a case of multiplying the numerators. 4 times 3 is 12. And multiplying the denominators. 5 times 1 is 5. And if you needed to convert that into a mixed numeral, that's 2 and 2/5. Okay. And then 55% of 680. Okay, and again, we've discussed the multiple ways of doing this. You can work out 10% is going to give you 68. 5% is going to give you 34. So if we know 10%, we can work out 50% by multiplying 68 by 5. Okay, 60 times 5 is 300. 8 times 5 is 40. So 340. Okay, and then we must remember to add the 5% on top of that. So that gives us 374. So 55% equals 374. Okay, guys, I hope you're remembering these past principles. If not, go back and look at the previous lessons that we've done. Go back and look at the online activities and memos. Brush up on those skills and make sure that you understand them and know them going forward. Okay, let's get into a bit of volume. Okay, so this is just a recap of stuff from grade 6. Volume of a cuboid. So we know a cuboid is a rectangle with depth. Okay, so a 3-dimensional rectangle. 2D, so we did 2D shapes, and we discussed that the area of the shape is the measure of the surface or the space contained by the perimeter. All right, so that's 2D. and the units of area for two-dimensional shapes was millimeter squared, centimeter squared, or anything squared. And that's the example of what a 1 centimeter square looks like. So this would be your area of the surface of one face of a cuboid. And you can see that that is going to be equal to 20 centimeters squared. Okay, and that's from 5 multiplied by 4, so length times width, 5 times 4 is 20. Okay, so that was area. Now we get to 3 dimensions, and that includes volume. So that is a measure of the space contained within the boundary of the object. So how much can we fit into that cuboid? All right. Units of volume are measured in cubes, so millimeter cube, centimeter cube, meter cube, kilometer cubed, okay? And that is what a cubic centimeter looks like. It's 1 centimeter times 1 centimeter times 1 centimeter. So notice that in area we're multiplying 2 dimensions, we get the answer in squares. For volume we're multiplying 3 dimensions together, so we have the answer in cubes. All right? So these would be the cubes that make up the volume of the cuboid. You can see that one face is 20 centimeters cubed. We have a second one at 40 centimeters cubed and a third one, and that gives us a total of 60 centimeters cubed. Okay? So the volume calculation would be length times width times height, 4 times 5 times 3, and that gives us our 60 centimeters cubed. Okay, go and work out the volumes of these 3 cuboids. There's one cube in number 3, all sides are equal, and then press play to see how you get on. For 1, your answer would have been 64 meters cubed, so 2 times 8 times 4. Okay, so there they've got the height at 2, the length at 8, and the width at 4. So multiply them together, and please notice the cube sign after the unit of measurement, which is meters. Question number 2, 2 times 3 times 5 is 30 centimeters cubed. And question number 3, 5 cubed, 5 times 5 times 5 is 125 centimeters cubed. Okay, so that would be volumes of cuboids and cubes. The next step that we go on to is volume of compound shapes. So very similar to the area and perimeter of compound shapes. So when we worked out the area of a compound shape, we split the shape up into different rectangles or squares, and then we added those totals together. So again, I'm going to ask you to go and try and work this out, and then press play to see how you get on. So we can work out the volume of the cube on the left, and it's a cube because all sides are equal. Please notice that it says not drawn to scale, so you can't take it that one length looks shorter than the other. You have to take the information as given. Okay, so they've told you the cube on the left, the sides are all equal to 8. So 8 cubed, 8 times 8 times 8 is 512 centimeters cubed. Okay, the volume of the yellow cuboid, the length is 12, the height is 3, and the width is 8 centimeters, and you determine that width of 8 centimeters from the cube, the length of the sides of the cube on the left of the diagram. So that's 288 centimeters cubed, and then the last pink cuboid is going to give you a volume of 5 times 2 times 8, and again you needed to recognize the width is 8, and that's going to give you 80 centimeters cubed. Our job's not done there, so now we need to add up those 3 different volumes, and we get 880 centimeters cubed. So well done if you worked out the volume of that compound shape. Okay, let's get on to the volume of prisms. So the first thing I'm going to ask you is, what is the difference between those 2 shapes on the screen? And quite correct, one's a rectangle and one is a triangle. We work out the areas of those shapes differently. We know that the rectangle is length times width, or length times breadth, and the triangle is half base times height, and the height is indicated by the arrow. So if I give you those measurements now, and they're exactly the same, you should be able to determine that the area of the rectangle will be 8 units squared, and the area of the triangle would be 4 units squared. Okay, now I'm going to ask you, what is the difference of these two shapes? And yes, you're quite correct in saying, well, the one is 2-dimensional and the other one is 3 dimensions. But just notice that the shape on the left is going to have similar measurements to the shape on the right. So if I asked you to work out the area of the rectangle on the left, you would tell me 8 units squared. And if I asked you to work out the area of the front face of the cuboid on the right, you would also say 8 centimeters squared. Okay? So where is this leading us? Well, here's a triangular prism. And again, you can see that the shape on the left will have an area of half 2 times 4 is 8. So therefore, the front triangular face of the triangular prism on the right will have the same area. Okay? The only difference is that it's now got depth of 6 units. All right? So if I gave you this compound shape, and I asked you to work out the area of the compound shape on the left, you would break it up into two, a rectangle and a square. You would work out that area. You would also do the same for the yellow face on the right. And the only difference between these two shapes is that the shape on the right has got depth of 5 centimeters. So here, what is the difference? Okay, one's a cuboid, one's a triangular prism. So what is this leading me to? Well, the shape on the left has got depth of 2, and the shape on the right has got depth of 6. So if I had to cut up both shapes into their front faces, then to work out the volume of the prism, I would have to go, the area of the rectangle is length times width. So you can see that there, 4 times 2, okay? And then the area of the triangle is half base times vertical height, which you can see is 4 times 4, which is 16, and half of that is 8, okay? But now we look at the volume of the rectangle or cuboid, and they've said you go length times width times height, okay? And that just means we go 4 times 2 and then multiply the 2. So it's the front face, the surface area of the front face that is repeated for 2 centimeters. And it's the same for the triangular prism. It's the front face with an area of 8 units squared that is repeated throughout the shape for 6 units. And there the volume of the prism is the area, so that would be the area of the front face multiplied by its length. Okay, so how would I calculate the volume of the cylinder? So we've already worked through the formula for the area of a circle, and we know that the formula for the area of a circle is pi times radius squared. And to work that out, it's going to look like that. And remember, we used pi on the calculator, or we used 22 divided by 7, or you could be used to use the value of 3,14. Either way, you're going to work out that the area of this circle is 50,24 centimeters squared. Okay, we know that 4 squared is 16, and then 16 times pi is going to give us that answer. So knowing that information, and we know that the area of the face of the cylinder is going to be pi times radius squared. So that's going to give me 3,14 times 3 squared. That will just give me the surface area of the circle at the top. And then we just need to multiply it by the height of the cylinder, which is 5. And that gives us an answer of 141,3 centimeters cubed. Okay, so to work out the volume of prisms, we calculate the surface area of a face, and then we just multiply it by its height for a cylinder. And as we saw for the cuboid and the triangular prism, we multiply it by its depth, because that face keeps repeating itself throughout the depth or the height of the object. So now we move on to capacity. And what I'd like you guys to do is I'd like you to have a look at the information I've given you on your screen, and I want you to calculate the capacity of these containers when full. You need to give your answer in liters. Okay, so the volume needs to be worked out, and then you need to convert it to the capacity. 1 meter cubed is equal to 1 kiloliter, and recall from the measurement lesson that kilo means 1,000, so that means 1 meter cubed is equal to 1,000 liters. 1,000 centimeters cubed is equal to 1 liter, and 1 centimeter cubed is equal to 1 milliliter. Okay, so see if you can go work out those three shapes and the capacity of those three shapes, giving your answers in liters. Press play and see how you get on. Okay guys, so we're on the Jamboard to work out these problems. So if we have a look at the first shape, you can see that the area of the front face is 24 meters squared. Just notice that the units are the same. Okay, so something to look out for is perhaps they give you 1 in meters and 1 in centimeters, and you'd have to convert them to the same units, and I would encourage you to convert them to units where there are less decimals or possibly no decimals. Okay, so I need to work out that 24 meters squared repeats itself throughout the whole shape. So if I slice that shape up, it would give me the same face of 24 meters squared going for a depth of 3 meters. So therefore my volume is going to be 24 multiplied by 3, and that gives me 72 meters cubed. And we can see from the yellow box on the right that 1 meter cubed is 1 kiloliter or 1,000 liters. So therefore 72 meters cubed is 72 kiloliters. Okay, and there is your answer in liters, 72,000 liters. Okay, so that's your answer for your first shape. Let's put that back. The second shape is a cylinder, and we've worked out how to work out the capacity or volume of a cylinder. So if the top face is 30 centimeters squared, right, that's going to repeat itself all the way down the shape for 25 centimeters. So my volume there is going to be 25 times 30. And again, notice that they're both in centimeters this time. So 25 times 30, 25 times 3 is 75. And then I need to include the 0 for the multiple of 10. So that's going to be 750 centimeters cubed. Okay, and if we have a look at our table on the right, 1 centimeter cubed is equal to 1 milliliter. So that's going to give us 750 milliliters. And we know that that is equal to 0.75 liters. Final diagram on the right hand side indicates 4 meters squared for the surface area of that front face. But then you'll notice that the depth of the object is 275 centimeters. Okay, so here we've got meters and centimeters. So you've got two options here. You can either convert that to 2.75 meters. Okay, and let's work that one out first. So the volume is going to be 4 meters times 2.75. Okay, we can go work that out. So 4 times 2 is 8. And then 4 times 0.75 is 3. So that's going to be 11 meters cubed. Right, and then if you have a look at the conversion chart on the right hand side, that's going to give me 11 kiloliters or 11,000 liters. So let's go see how it works out if we convert it both to centimeters. Right, so I've already converted the 4 meters squared into 40,000 centimeters squared. Remember, it's not a straightforward conversion like meters into centimeters. So 4 meters squared is not 400 centimeters squared. If you need to brush up on that, then go back to the measurement lesson we did a few weeks back. 1 meter squared is 100 centimeters times 100 centimeters. Okay, so 10,000 centimeters. So 4 meters squared will be 40,000 centimeters squared.
So now that I've got both measurements in centimeters, I can multiply 40,000 by 275. That gives me 11 million centimeters cubed. And then to convert from centimeters cubed into liters, I divide by 1,000, and that leaves us with 11,000 liters. So you get the same answer. Your numbers are just a lot larger. But you need to choose if you prefer working in decimals and keeping the numbers smaller, or if you want to get rid of the decimals and therefore make bigger numbers. Okay?
Guys, that brings us on to our finisher for today, which is the game of 24. Use each number on each card and try and come up with the answer of 24 using plus, minus, multiply, and divide. So for example, on the first card, you could say 2 multiplied by 8 is 16, plus 2 multiplied by 4, which is 8. 16 plus 8 is 24. I hope you guys are challenging each other at home and finding a bit of enjoyment out of it, and I hope that your mental arithmetic is improving from doing so. Grade 7s, thanks very much for joining me today. I hope you guys got something out of volume and capacity. Please go have a look at the online activity with Memo. There are quite a few examples there for you to work through so you can consolidate the information that you've learned. Please feel free to go back and have another look at the lesson if there are any areas that you're unsure of. And as I've mentioned before, there are numerous online lessons that we've been doing over the last 7-8 weeks, as well as online activities and memos for you to have a look at, and please make the most of those opportunities that we're providing to you. Guys, have a great day, and I look forward to seeing you next time. All the best.